This video, we will cover the topic of function applications. For our first example, we are given some information in a table that compares the amount of money that Anne saves versus the amount of money that Kyle saves. The information is given to us in the form of a table, and we're asked to plot the points on this coordinate plane. We're to use clues from the table and the graph to write an equation in slope-intercept form for Anne's savings. So Anne is our output, that is our y value. Kyle's value is the x, or the input. You can see the x value, input, that's our independent variable. And Anne's savings is related back to Kyle's savings. So Anne's savings is our dependent variable. And so if we use the numbers in the table, we go across our x-axis to 2 and up our y-axis to 6. For the second point, we would go across to 8 for Kyle's savings and up to 18 for Anne's savings. If we count up by 2s, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, and you make your point. For the third set of data, we have Kyle's value is 10, so this is 8, 9, 10. And then up to 22. So we count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. The next set of data is when Kyle saves $12 and saves 26. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. And our last set of data says that when Kyle saves $14, Anne saved $30. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and 30. And that gives us some points, and those points appear to be in a line. So what we need to figure out is two things in order to write our equation. We need to figure out our slope and our y-intercept. So we can get either from the table or from the graph. I'm going to start with the graph because this is our data that we connected. I'm going to make a nice straight line that goes through the limits of our graph. And when we do that, we should be able to see here our line or our equation. So if we wanted to find our slope and our y-intercept, start first with our slope, find 2 points, and you figure out the slope by moving from one to the other. So from here to here, we would go up 1, up 2 lines, but when we're going up each line going up is worth 2. So this is up 2, up 4, and according to our scale going across, each one is only 1. So that is over just 2. So it appears as though our slope is up 4 over 2. Both of those are positive. A slope dude would say puff, puff, positive, going uphill. And that simplifies down to the whole number 2. So that's my slope. My y-intercept would be what is this value here if I continued down to where it hits it. So it would be down to left 2, and it's hitting right here. And remember, when we count up, this is 2, 4, 6, 8. So this point right here is 2. So my y-intercept is 0, 2. And given those two pieces of information, you can write your equation in y equals mx plus b, where slope, remember, is your m, and b is your y-intercept. So my equation would be that y, Anne's savings, is equal to m, which is 2, multiplied by x, plus b, which is a 2. And that's the equation of our line. So where X is Kyle's savings, if we double Kyle's savings and add 2, we should get to Ann's. So just double check it. If we doubled 24, we would have, or excuse me, if we doubled 12, we would have 24 plus 2 more gives us 26, and it works. So let's take a look at a second example. The second example is given the information that you see on the bottom, excuse me. Sorry. It says the first time you measured a tree, it was 1 meter tall. So the first time you measured a tree, that's time 0. It was 1 meter tall. The tree kept growing at a constant rate. Plot the ordered pairs from the table. Use the clues to write the equation in slope-intercept form. So my time is my x, that's across the bottom. X, input, independent variable. The thing that depends upon the time is how tall the tree is. And so that would be our dependent variable, which is why it's on the y-axis, and that would be our output. So if you graphed your ordered pairs at 0, or 0 in time, the beginning, it is 1 meter tall. So from here, 0, 1. Looks like each line going up is worth half a meter, and each line going across represents 1 year. So it's really important that you figure out your scale. For the second data point, the time is 4 years, so we go across to 4, and then we go up to 3. Not just up 3, remember, each line going up is worth a half. So 1 half, 1, 1 and a half, 2, 2 and a half, 3, and you can see the 3 on the side. In 6 years, so it's 4, 5, 6 years, up to 4 meters tall. So from here, 6. I go up, that was 3, 3 and a half, there's 4. In 8 years, which is this line, it's 5 meters tall. So I'm going, there's 4, 4 and a half, there's 5 meters tall. And the last point is in 10 years, which is right here, halfway between the 8 and the 12 on my x-axis, I go up to 6 meters tall. So there's 5 meters, there's 6 meters, and you make your line by connecting your dots. And once you have your line made, you can read your slope from the graph. In this case, we also have our y-intercept, or we can get both pieces of information out of the table. So I'll show you both versions. Let's start off with the slope from the graph. The slope from the graph, pick any 2 points that you made and figure out how far do you go up and how far do you go over, your rise over your run. So if I go up 2 lines on my graph, that's only up 1 full unit, because remember, each line going up was only half a unit. So I'm going up 1, and from there I go over 1, 2, and on the bottom, each one across, or each line across, represents 1 full year. So I'm going to go over 2 years. So my slope in lowest terms would be 1/2. You can get that same information right here from your table. Pick any 2 points that you'd like to go. I'll go from 1 to 6 and 0 to 10. So their partners are lined up. You just want to make sure that if you're picking points whose partners line up. So the change in y, I go from 1 to 6, that's up 5. And over here, I go from 0 to 10, that's up 10. The change in y is 5. The change in x is 10. And that also goes down to lowest terms, 1/2, which is the same 1/2 you got. Remember, slope, that's your m. Now for my y-intercept, I can look right here. When x is 0, y is 1. So my y-intercept is 0, 1. And you can also see that information right here from your table. When my x is 0, my y is 1. So that point right there, it was given to you as your y-intercept. And your y-intercept, remember, is the letter b. So if my equation is in the form of y equals m, that's 1/2, x plus b, b is a 1. And so the equation of this line is y equals 1/2 of x plus 1. Double check that that works. Just pick a point, maybe a point we did not use. For example, 8. 1/2 of 8 is 4. 4 plus 1 is 5. And it worked. And so those are two examples of word problems, function applications, where you can make the graph and from the graph determine the slope and the y-intercept to create your equation in slope-intercept form.